We've just got to finish up the last little bit of our section 12.2. I didn't want to rush through this, although I think you probably could have figured out most of the stuff on your own if I had left you to your own devices. So the last couple problems are just reading graphs. So just to get you back up to speed, we talked about frequency distributions and creating them. And then from frequency distributions, we created histograms and frequency polygons as graphs. And then the last thing we did was a couple stem and leaf plots. And so that brings us to where we are today. So this is example 9. I think it's the 4th page on the handout that I gave you, very bottom. And it says, we've got this histogram that's been provided for us. And we're actually going to do 3 of the 4 problems. We're not going to do one of them because I think you have to make too many assumptions to do it well. And I don't think I want to do that with you. So it's just about reading this. It's reading this histogram. So I'm going to have you do them, and then we're going to follow up. Because again, I think once you know how to make a histogram, reading one is not necessarily the hard part. So I'm just going to give you 30 seconds, and maybe even a little less, to do the A problem. Figure out for me how many students were surveyed according to that histogram. All right, so what's the procedure to figure out how many students were surveyed? What'd you do? I'm sorry? We look at the graph. And what part of the graph do we look at? Yeah, we're gonna look at each bar, but then we're gonna look at the y-axis, and we're gonna see how many students are, how many students are in each of the bars. So this first bar represents how many students? Yeah, I'm just going to write it right above just so that you know where these numbers are coming from. So this first bar represents 2 students. Then the next one represents, so far I got a total of 6. The next one represents 6 more, so that's 12. And then if I'm reading this right, this bar represents 8, so we're up to 20. And then 7 for 27, and then 3 for 30, and then a lone student out there for 31. So the answer to that is 31. So far, so good? Okay. We are not going to do the B part, so you can just cross that out. That's not a question I'll hold you responsible for on the test. So then what I would like you to do is the C part. How many students have an annual car insurance premium in the class with a class mark of 752? I'm going to give you, again, 10 seconds, 15 seconds to write down that answer. And so how many students are in that class right there? 6, yes. Again, these problems are just about reading our graph. So here is the 752 class mark, and that bar has a height of 6. Last one is what is the class mark of the modal class? So this presents us a new word. We're going to work with this word a little bit in our next section, but modal means most. So which class, basically what this is asking is which class has the most students in it? I'll give you 10 seconds to write down the answer to that problem. And which class has the most students? Yeah, 803. Okay, so the $803 class is the modal class. Okay, example 10. This time it's the same sort of thing, but with a frequency polygon instead of a histogram. So I'm going to give you like 90 seconds. Answer the 3 questions to example 10, please. All right, so the first question says, how many families visited the San Diego Zoo 4 times? So what's the answer to that question? Yeah, so again, if you don't know where you're looking, here is the number 4. The x-axis is the number of visits. So then I just go look upward, and that's where we get the value 8. Fantastic, great job. Everybody tracking with me? I'm going to ask you a couple questions about reading a graph. I hope this is a breeze and nice and easy points for you when you take your test. The test is a week from today, so that's going to be your final unit test. How many families visited the zoo at least 6 times? So at least means 6 or more, so that is how many? What would you say? 24, great. So where did we get the 24 from, in case you didn't see? Well, 6 is 11, if I'm reading this right, and then 7 is 9, and then 8 looks like it's 3, 9 is 0, 10 is 1, and that is my 24 that I was given as an answer. Great job. And then last but not least, how many families were surveyed? We do the same thing here that we just did for the histogram. I'm just going to add up all of the values. So we've already got 24. And then here at 5, we've got, what's that, 6? Correct me if I'm wrong. And then we've got 8 and 8, and then 2, and then 4. So let's see, that's 24, and then 30, and then 46, and 52. Did I add that up right? Okay. Everybody seeing where these are coming from? All right, again, just making sure that we're comfortable reading graphs after we constructed them. The last thing for us in this section 2, and then if you have any questions about anything we did or anything, please ask, is pie chart. The only thing we talk about pie chart, we don't really talk about making them in this class. We just talk about reading them. And so this problem says 800 people who attended a circus were asked to indicate their favorite performance. Use the circle graph representing the data to determine the number of people in each category. So notice our pie graph. Normally, some people label pie graphs with the numbers, but most pie graphs are labeled with percents. And so what we want to do is we want to translate. So I want to know how many people like the Tigers. And I'm told over here that 38% of people that responded liked the Tigers best at the zoo. So basically, this isn't even really about the pie chart. This is about working with percents. How am I going to calculate how many people this pink piece of pie represents? I'm going to multiply what? Yeah, the 800 is the total number of people. That's exactly right. And then I'm going to multiply that by the 38%. And the way we do that is you never use a percent the way it is. You always got to make it a decimal. So 0.38. Yes, exactly. And so then at this point, just becomes a calculator problem. So 800 times 0.38 turns out to be 304 people liked the Tigers the best. So again, this is just an exercise in reminding you how to work with percent. So I'm going to give you like 90 seconds, maybe 2 minutes. Go ahead for the other 4 and just determine how many people each of those wedges of pie represent. Okay, again, most of this is just calculator work. So elephants, we noticed 26% of people liked elephants. So I'm going to take the 800 total times 0.26. I'll come back and do the calculator portion of that in a minute. Acrobats, and so we just do the same thing for each of those. 17% of people liked the acrobats flying around, and then 14% of people liked the jugglers, and then finally other acts, 5%, so 0.05. So again, the main attribute of this exercise has really not much to do with the actual pie graph and more to do with the percents. So 800 times 0.26, you should have got 208 people right here. And then 800 times 0.17, whoops, I don't know what I just did there. That's better, 136. If you got something different than me, it probably means I pushed the wrong button on my calculator, so please let me know. The next one's 112. And last but not least, 0.05 times 800 is going to be 40. And there we go. That's how the people are distributed according to the pie graph.